Hello, welcome to part 8 of 30 days JavaScript challenge. And last three questions were easy related to arrays, but they were really important, at least in my mindset, because of the way in background the arrays work. Now let's see what all functions have. Function composition, okay. Given an array of functions, return a new function that is the function composition of the array of function. Okay, this language itself is getting complicated. There's an array of functions, f1, f2, okay. Then we need to create a final function, which is a combination. Composition can be termed as a combination of all these functions, okay. Now, how do you combine them? This is the logic, okay. So if there is a function x, fx, gx, hx, this is similar to what we used to do in mathematics in India. We used to do it in class 10th or 11th, not sure everywhere else, but yeah. So basically, x is a variable in which you can pass anything. So what you can pass? Let's pass gx, and that's how you pass. Then it becomes f function which has gx, which is g function x value. Now x again, you can pass anything which is hx, and therefore in the end you get fghx. Okay, and whatever is the final. Okay, if the array is empty, we provide the value of x as a result, which is called the additive function. Okay, this is actually mathematics. Okay, sorry for that. Now let's start with this. Let's understand this. This is the first function. This is second function. This is okay. There's one thing actually. I think if I'm not wrong, if we are writing something like this, x is part of the innermost function, which means the innermost function is getting solved first. Whatever is the result gets passed to g of x. Okay, this g function will accept that as a value. Whatever this g function solves, that result will get passed to f function. Okay, and then it will solve it. So basically, we are starting with the last item of the array, solving x and going backwards. So that's actually important here. Functions. This is the first one. This is the second one. This is the third one. Let's x is 4. So 4 plus 1, 5. X will be 5. Let's pass it here. Sorry. X is 4. We are passing 4 here, which will become 5. Then we pass 5 here, which will become 25. Then we'll pass 25 here, which will become 50. Oh, sorry. I just now said it that we have to start from this side. So x will be 4. 4 will become 8 here. That 8 will get here, which will give 64. 8 8 is 64. That 64 will go here and give 65. Correct. So first is reversing the array and then just keep on solving it. I think, yeah. This is the functions. Okay. I'm just checking actually. No, if else. Let's start with, okay, let's check first if the size is empty. If the functions, overall functions, remember, don't get confused. Functions is an array here. Okay, so if this array is empty, we will return whatever is x. Okay, because that's what the identity function is. Okay, now if there is no such thing, if there are functions, then let's iterate over it. So for let, but I'll have to first reverse it. So instead of reversing it, what I'll do is let I equals to functions dot length length minus 1, starting with the last index, I greater than equals to 0 colon I minus minus. Okay, we are reverse iterating the functions basically. Okay, now from this we'll get the current function. Okay, this will give us first x, then next loop it will give us gx, and next loop it will give us fx. So this is the function. In this function we have to pass whatever we are getting x. Okay, once we get that value, we should store it somewhere and keep on passing it. What for that, what I will do is let result equals to x. Let's pass result here. So it is exactly similar to that, but now we'll keep on updating the result. And yeah, I don't think we need this condition. Let's get rid of this and let's return result. Let's try to run this. It might be a confusing one, but let's do. Yeah, it was correct. So basically, this is the function that we got. In that, we pass the result, iterating over it again and again. And yeah, that's it. So again, a straightforward thing, but really nice to understand the function composition. By the way, this is one way I'm currently working at Esprinto, and this is one thing that they have implemented similar to this. I won't say exactly this, but it is similar to this. They have created something called as conveyor. Okay. Now, what is a conveyor in real world? It's a piece of machinery where you put on items and that item keeps on changing. Okay. For example, the simplest thing that I can think of is okay, there is no such example in this, but this is a conveyor belt. Okay, what happens is that at the first step, you can see that, okay, let's say there's an iPhone factory. So they have an iPhone that comes, they have a box that comes up, that second part, they have labeling over that, that's third part, and finally seal packing it, fourth part. Okay, so on conveyor belt, all these things will come and it will keep on changing, finally to give a final product, which is the entire iPhone set. Okay, now each and every one of these items, first item depends on the second one, first function depends upon the getting the iPhone, after that it depends upon packing the box, after that it depends upon printing on the box, and after that it depends upon covering the box. Okay, so everything can be done if the past function has returned something, right? So that's how a conveyor belt works. Okay, one after another, one after another, one after another. We did something similar here also, and in my company also, they have created a conveyor function, which basically does this only. You get call a one API or one function. That function gets done. Whatever is the result of that gets passed to the second function. Whatever result of that gets done, passed gets to the third function, and it makes overall coding really easy. So yeah, that's it. Thank you. Bye bye.